Welcome, everybody. I'm super excited about this next session. We have some great members of our faculty here to talk about how you can use some of the LLMs like ChatGPT to hack AEM in your regular clinical and administrative life. So I'm not going to take too much time now, but I'd love for you guys just to introduce yourself and we can get going.
Yeah, thanks for the intro, Dan. Nice to meet everyone. My name is Dong Yao. I'm a clinical informatics fellow at Stanford. My background is in emergency medicine, of course. And Carl?
And I'm Carl Preiksaitis. I'm a clinical assistant professor here at Stanford as well. I do AI work and medical education work.
Okay, neither of us have any conflicts of interest. Okay, so we are going to spend this hour talking about how to use LLMs like ChatGPT more effectively. And in order to best do that, I think it's important for us to build a good, solid foundation of knowledge about how LLMs actually work beyond just the basics, so we can kind of start to get an intuitive feel for what works, what doesn't work, and why it's working or not working. From there, we're going to try to arm you with a toolkit of a few high-yield, must-know prompting techniques. And then finally, we're going to wrap up with a live demo of some sample use cases. But before we do all of that, we have a quick poll. Let's go ahead and throw that up and maybe take 15 seconds to answer it. It's just a single question. Are people seeing a poll? There we go. Okay. And while people are answering this poll, I'm just going to be going through my slides for the first 20 minutes or so. If anyone has any questions, there's a question and answer button at the bottom that you can click. Go ahead and type in your questions, and then once I'm done, I will go through and try to answer as many of them as possible. Okay, we're going to do like 5 more seconds. And then Nicole, whenever you feel like we can close the poll, go ahead. Nice. Okay, interesting. A pretty bimodal distribution. Most people are using it all the time, but some people have used it before and not really using it anymore. Okay, perfect. Kind of what we expected. So, taking a step back from healthcare, we've had AI for a long time. We have Alexa, we have, Siri, and we basically ask them basic questions and we get basic facts and answers back, sometimes well, sometimes not well. And seemingly overnight, we went from that to this, where we are now having complex discussions with ChatGPT about philosophy and finance and math and medicine and linguistic theory. How did this happen? In other words, what the heck is happening inside this black box that is causing such a dramatic difference and a dramatic improvement in the output? And so the more we work with these LLMs, the more we realize that in order to sort of best understand why you're getting the kind of outputs you are, it's best to sort of try to understand a little bit more about how these LLMs actually work. And so with that in mind, let's try to make some sense of the black box. So we start with an input prompt. Let's say we start with the following prompt. Please help me draft a short but professional letter to a patient explaining why they don't need an MRI for their seasonal allergies. The first thing the LLM is going to do is it's going to split the input prompt into smaller, more manageable tokens. These pieces are called tokens, and the entire process is called tokenization. The tokens can be words, it can be part of words, it can be characters. For the sake of simplicity, you can kind of assume that one token is roughly equal to one word, and sort of moving forward, we'll use the words word and token interchangeably. And so here is how GPT is going to tokenize this particular sentence. It's going to break it down into these actual 25 tokens. The next step is to turn each of these 25 tokens into something that's called an embedding. An embedding is a numerical representation of the complex semantics of a token so that the computer can essentially understand what the token or word means. And this entire process is called encoding. To illustrate this, let's take a look at this word patient. The numbers in this embedding or in this string represents the complex semantic meaning of this token in a high dimensional space. Let me say it one more time. The numbers in this embedding represent the complex semantic meaning of this token in a high dimensional space. Now, if you're like me, I have absolutely no idea what that sentence means. So let's try to break it down a little bit. This is a vector. A vector is just a numerical array of numbers. In this case, there are 3 dimensions because there's 3 numbers. In this case, this vector might represent a force diagram, 5 newtons in the x-axis, 1 newton in the y-axis, 7 newtons in the z-axis. It might represent color using the RGB model. Could represent anything. In this case, this is an nth dimensional vector because there's an unknown number of numbers. But this nth dimensional vector doesn't really have any meaning until we give it one. And so an embedding is a very specific kind of vector where each dimension or each number in the array represents the strength of the association of that particular token with a particular sentiment ranging from -1 to 1. And so together, a large enough array of these numbers can holistically capture the complex semantics of a particular word. And so looking back again at the sample embedding for the word patient, if we look at each of these numbers, they range from -1 to 1. 0.84 might represent positive versus negative sentiment. 0.64 might represent the likelihood that this word is a noun. -4.6 might represent emotional intensity, and so on and so forth. And so in this way, a huge amount of these numbers in the embedding represent the detailed and complex semantic meanings of a word in a way that we humans might not be able to understand. And so here is a visual representation of what that might look like. This is a very basic vector space representing 3 dimensions, the tail, legs, and speaks dimension. And you can see that in this particular vector space, the vector or the angle between the concepts of cat and dog are closer than the angle between cat and human. And so in this vector space, the computer understands that cat and dog are semantically more similar in concept than cat and human. So how many dimensions does a typical LLM use to capture the definitions of a single token? This is what 1,000 dimensions looks like. And already you can see that we're exceeding our human capacity to understand what the nuances of this word is, right? I might be able to define patient in 2 or 3 or even 4 ways, but it's really hard for me to define patient in 1,000 different sentiments. But even this is a pretty dramatic underrepresentation of what these transformer models do. This is how many dimensions GPT-3 has. It's 12,000 dimensions, and this is an actual representation of what 12,000 dimensions looks like written out. And so if we go back to our representation of these vectors, the way I think about these embeddings is that it looks less like this and more like this, a dense model of a dense electron cloud, where the nucleus in the middle represents the token or the word, and the cloud of where the electrons could be around the word each captures the different dimensionality of the totality of the complex semantic meaning of a particular word. And so going back to our model, the numbers in the embeddings, the values of these initial embeddings, where are they coming from? Well, they're coming from the pre-trained model. The LLM has essentially learned the complex semantic meaning of language, and by extension, the association between the different words and ideas through all of its training inputs. The models are essentially trained on a huge variety of inputs, and essentially the entire open internet, and through that has learned the different relationships between the different words. And so this is where something interesting happens. These initial standard embeddings are transformed into what we would call context-aware embeddings through a mechanism that's called the self-attention mechanism. Through this step, the model is now able to identify the most important words and nuances of the input prompt needed to generate the most relevant output. And so going back to our example here, if we start with the word patient, which starts with this embedding, the word patient might have different meanings depending on which context you use it in. It might be a noun, it might be an adjective. So as the word patient and the embedding gets moved through the different transformer layers, they get transformed and the embedding gets fine-tuned to the context of the current conversation, and the importance of each word in the entire input prompt gets recalculated. And finally, you have at the end what we will call a context-aware embedding. And once we have all of these embeddings for every single token, they get all put back together and turned into an output. And so in the previous step, all of the tokens are transformed into context-aware embeddings, and all of these embeddings are stored in a big matrix of numbers that is known as an embeddings matrix. Every row in this matrix is essentially the context-aware embedding, the big string of numbers of just a single word or single token. At this point, something interesting happens. Based on the embeddings matrix, the probability of the next token is calculated based on the complex series of mathematical formulas, and based on the probability distribution, the next output token is selected, in this case, deer. This is where the variable temperature comes in. We won't get into it too much here, but temperature is essentially a setting that you can tweak to change the probability distribution of your output to get more or less deterministic outputs. It's also important to note that for every single generation cycle, only a single token is generated each time. And so based on this new token deer, the entire embeddings matrix is recalculated to accommodate the added context of this new word deer. So let's go back and look at how this works in our example. Based on the embeddings matrix of this input, the next output token might look something like based. This is the end of cycle 1. In cycle 2, the token gets placed at the end of the input token and actually becomes a part of the new input prompt. The new embeddings matrix is then calculated, which takes into account the added context of this new token, and then the attention mechanism adjusts the weights such that it now focuses on what's newly relevant, and based on these new embeddings, the next word and the next token is calculated. And this iterative process essentially repeats itself over and over again for each individual token, with the token being added to the end of the chain until the final output is complete. And so in this way, the LLM is essentially building out its output one token at a time. It has no idea what it's doing when it starts writing, and has really no idea when it starts writing where it's going to end up. This is a really important concept to grasp in understanding how LLMs think and how they reason. So let's review it one more time. One token is generated each time. At the end of each cycle, that token is fed back in to be a part of the input. The LLM then uses this new token to generate additional context for future cycles. And so with every added word generated by the LLM is guided closer and closer and closer to the answer that you sort of expect and you want based on probability and math in the vector space of solutions. And so this is a fundamental aspect of how LLMs think, and sort of why chain of thought, which is something we're going to bring up in a little bit, actually works. And so to go back to earlier question about how LLMs can magically take these abstract concepts and seemingly give you really nuanced and abstract outputs, we can now understand that the LLM is essentially behind the scenes just a fancy de-abstraction and re-abstraction tool, where you start with this abstract idea or concept that is conveyed in language, which then gets iteratively broken down through a series of steps into more and more discrete and finite concepts, ultimately ending in math. You do the fancy math, and then the LLM puts it all back together into a form that we collectively recognize as language and as reasoning. Okay, so part 2, the prompt. In other words, now that we know a little bit more about how LLMs work, what is actually the best way to talk to this AI? Let's start by defining some pretty confusing terminology. So prompting is the process of providing a prompt or an input to a generative AI model, which then generates a response. A prompting technique refers to a specific described blueprint or specific style on how to structure the prompt so that you get a specific kind of output. And then finally, prompt engineering is putting it all together, is the iterative process of developing this prompt and adjusting and changing the technique to sort of get to where you want to be. More on prompting, there's also 2 different styles of prompting that are pretty different. So personal prompting is probably what we all do day to day, right? It's asking it basic questions, getting basic answers back, maybe doing basic math, performing basic tasks. Whereas production prompting is getting LLM to do a very specific task, like labeling a big data set or creating a piece of an automation pipeline. And so the outputs need to be very structured and very accurate. And sort of as a result, these prompts are highly structured and sometimes can be thousands and thousands of tokens long. And so this is what that might look like, right? For personal prompting, edit this email. What does this word mean? Help me come up with this basic task. Whereas production prompting, you can see, is sort of fancier and many paragraphs long. So let's start with some basics. These are probably things and terms that you have heard before, but it's definitely worth re-examining. So let's start with an easy one, role prompting. You've probably heard of this. You are the best ever blank. You are an experienced blank. You have a PhD in blank. How much does specifying the role actually help? Well, let's take a look at this basic knowledge-based task. What is the correct way to manually detorse a testicle? We're going to use two different prompts. Number one, you are a genius level professor in emergency medicine with over 35 years of practice experience. Number two, you are the worst ER doctor ever with a fake online medical degree, and the only patient you have ever seen is a plastic man from the game Operation. What do you guys think the outputs are going to look like? Surprisingly, they're more or less the same, right? These are the actual outputs from GPT-4. The online medical degree doctor knows about positioning and knows about opening the book, right? Pretty good. And so for accuracy-based tasks like knowledge answering, role prompting doesn't actually make a big difference in improving the accuracy. Someone actually did an experiment of this. They made two separate role prompts, one genius prompt and one idiot prompt. So for the genius prompt, it ends with, you are omniscient, you are omnipotent, you are omnipresent, you are a mathematical god. And the idiot prompt ends with, you fail at everything you do, you can't do anything right, and you are a nobody. They then ran these two prompts against a standardized set of 2,000 multiple choice questions that's commonly used to evaluate LLMs, ranging from different subjects from math, law, geology. And sort of to your surprise, the roles actually didn't matter at all in determining the accuracy, right? It didn't matter if you were answering the questions as a farmer, as a police officer, as a professor, as a student. And in fact, actually, the single worst prompt was the genius prompt. And so if you've been doing this, where you put a bunch of things behind the role that say you are an expert in this, you are board certified that, you can actually feel free to drop that. It doesn't really make any difference. So if the role doesn't really increase the accuracy, then you might ask, what is it good for? The way I like to think about the role is it's the best shortcut to specify the style and tone of your output, which in fact actually does make a huge difference, which brings us to our second point, indicating the appropriate style and tone. In this case, you want to be friendly, professional, empathetic. And so here's a basic prompt again for a common ED task. Give me return precautions for renal colic. Let's see how this prompt does. Not bad for something that took just 3 seconds to type, right? A good reminder at this point that even though LLMs in 2024 are really good and really accurate, they still hallucinate, they still have errors. So, for example, here in point 7, it's warning you about swelling in the flank, which obviously is not really a thing that happens with renal colic. Let's see what happens if I add a new line specifying the tone and style. Give me return precautions for renal colic in a compassionate, thorough, and narrative format. Starts with, I'm glad we could help you today, and I know how painful kidney stones can be. Now, note that I didn't really ask for a first-person perspective, but in specifying the tone to be compassionate, the way the transformer LLM architecture works is it knows that the words and phrases written from a first-person perspective are semantically closer in meaning in the vector space to the idea, the abstract concept of compassion, and so it writes it in a first-person perspective rather than a third-person perspective. Okay, let's try another example. You are an emergency medicine physician. Write me return precautions in a tone of a Gen Z doctor. It says, all right, fam, here's a T. Fever equals bad vibes. Again, pretty accurate response. It gets everything right, but it does it in a totally different way. Finally, let's look at this last example. Write it in the cell of Groot from Guardians of the Galaxy. Pretty good. It writes it as Groot. And so you can see that specifying the cell leads to a very, very dramatic difference in the output, different than in the role. Next, this one, giving a clear goal, it's pretty self-evident. The more unambiguous you are about your language, the more likely you are to get something that's more usable. We'll come back to this point a little bit later. And then finally, we have delimitation, which is specifying and highlighting unique sections of text with some identifier, usually hash marks, backspaces, backticks, backslashes rather. And the reason that this works is because during the pre-training phase, the LLM has read billions and billions of lines of code from Python and JavaScript, and a lot of these coding languages use these common symbols as comments and as section separators. And so when the LLM sees this in your prompt, it knows that this area of text, which in this case, let's say might represent PMH, it knows to treat this section separately and treat it as a separate entity. And so putting this all together, you can already see that we have a pretty basic prompt for creating return instructions, but you probably don't want to type this prompt in every single time you have to make the discharge instructions, especially if you've taken the time to tweak it to your liking. So where can you save these prompts so that they're in line and easily accessible with your clinical workflow? Well, you can try adding it to your dot phrase library. This is what I do. So whenever I am on shift and I want to use a clinical prompt, instead of typing it into the GPT or going to a Google spreadsheet and copying and pasting it, I just type in a shorthand .gpt prompt. And it actually spits out not the discharge instructions, but it spits out the prompt for the discharge instructions. The nice thing here is that if you want to be fancy, you can go in and add relevant patient context, smart elements like their name, their age, relevant conditions, their past medical history, etc. And then when I type in .gpt DCI, I get this thing, which I then quickly copy and paste into our secure GPT. And then I get this back in like 2 seconds, and then I paste that in. So you can try experimenting with something like this. It might take you a few dozen attempts to make small tweaks here and there, but eventually you'll get to a point where it's actually pretty good 80 to 90% of the time, and you end up getting something that's much higher quality and takes much less effort. And so in the last few minutes, let's talk about some more advanced prompting techniques. Here is a small snapshot of all the different techniques out there. It is an overwhelming amount. And unfortunately, this is one of the biggest problems in trying to keep up with prompting literature, which is what I've been trying to do in the past year or so. There are just way too many individually described papers and techniques on this to keep up with, and there's very little standardization in the process. And so someone wrote this really excellent systematic review on all the prompting techniques out there in the ether, and they summarize it into a very, very short manuscript of just 76 pages. And what they did was they took over 4,000 manuscripts. They did a bunch of different things to it. They actually used a little bit of automation, and they ended up identifying 98 different unique, different prompting techniques. Now, how important is it to know each of these techniques? Turns out, probably not really, and here is the reason why. For ChatGPT alone, in the last 2 years, there's literally been 18 different model releases, and each and every single one of these releases, the capabilities improve and they change. So here's a particularly salient quote from someone that builds these frontier models. They say, every single time we discover a new hack or a new trick, what they think about is how can we incorporate this into the foundational build of the next model? And therefore, for these reasons, the best hacks are always going to be short-lived. And so if most of these prompting techniques are short-lived and essentially irrelevant, then is there anything that is good to know and is always going to be necessary? Now, it turns out we went through this entire 70-page manuscript, and we did actually identify 3 things that is important to know and are very, very relevant. All 3 of these techniques, if you use them correctly, lead to dramatic improvements in accuracy and quality, and more importantly, all have fundamentally remained relevant because of the way LLMs work. And so these 3 techniques are few-shot learning, chain of thought, and giving clear instructions. Don't take it just from me. This is Sanders Schulhoff. He is the founder of the most widely used prompting education website, Learn Prompting, and also the first author of this manuscript. And he literally says, despite all of this, my toolbox just consists of mostly few shot, chain of thought, and including very good information about the problem. And so to briefly give everyone a 30,000-foot view of each of these techniques, few shot learning is essentially just giving examples. In LLM speak, an example is referred to as an exemplar. Here's a 0-shot example. Here's a few shot example, specifically a 4-shot example, where it gives 4 examples on how it wants the task answered. And so the way you give these examples actually really, really matter, right? You want to avoid over anchoring. So generally you want to include between 5 to maybe 20 examples. You want to make sure that the examples are representative of the production distribution. And so the ordering actually really matters. For instance, if you add all the positive examples first and then add all the negative examples at the end, the model actually reads into that and then thinks that's a pattern that's important when in reality it's not. And then finally, you want to make sure it's formatted correctly. And so in this 3-shot example, unless your data set consists exclusively of, old female patients, what you really want is probably something more even and uniform and normal, like this. Next is chain of thought. A lot of you have probably read this book, Thinking Fast and Thinking Slow. Daniel Kahneman sort of describes 2 systems of thinking, the fast, unconscious system 1 thinking and system 2 thinking. LLMs, unfortunately, always default to system 1 thinking, right? They literally cannot plan, they cannot reason, they can only predict the next token. And so our goal is to figure out how to get from system 1 to system 2 thinking. And we use a technique called chain of thought prompting in order to accomplish this. And chain of thought is basically a fancy way of saying we are forcing the LLM to write down its thinking process and to show its work. And so here, as an example, we're trying to have this LLM do a math problem, and here is a one-shot example that arrives directly at the solution without showing its work, and it gets the solution wrong. But if we incorporate chain of thought by incorporating how we arrived at the answer and breaking it down into the individual steps in that one-shot problem, it actually gets it right. And the way this works is essentially breaking down complex problems into smaller parts, and so that each of these smaller parts are easier for the LLM to guess right based off of just math and probability. And also, each step in the reasoning, as we talked about, sort of guides the LLM towards a sequence of tokens in the vector space that is probably the answer that you want. And then finally, by generating more context for itself, you are optimizing the LLM's attention mechanism. Remember what we talked about earlier, the only way to get this to work is you have to generate the output. You have to tell the LLM to generate its output. You can't have it think inside of its head because there's no such thing. And then our last technique is perhaps the most important, but probably the hardest to get right, and because there's no blueprint for this, and this is giving clear instructions. And so all the basics we just covered actually technically all fit into this. But beyond the basics, giving clear instructions is essentially how can you take an incredibly complex problem space and break it down into individual smaller pieces or steps. Now, a bunch of people have tried to explain this, but the single best explanation that I have heard is by this lady, Amanda Askel, who leads an alignment team at Anthropic. She's, of course, a very good prompt engineer, and she talks about this concept of externalizing your brain. So remember, the LLM is an expert in many things, but it knows nothing about the context of your problem. Only you are the expert in your own problem space. So in order to work well with this expert LLM, you need to give it as much context about the problem as you can. And so when people go to her for advice and say, hey, I have this problem that I can't solve with prompting, she actually asks them to describe the problem to her. She says, like, tell me about your problem. And these people think about the problem and they sort of tell her the problem. And she says, great, that's fantastic. Literally write down everything that you just said, put it into the LLM, and that will get you 80% of the way there. So the way I think about talking to an LLM is like talking to an educated layperson, right? They are very smart, but they don't know anything about this specific topic. And you need to figure out how to talk to this educated layperson who knows nothing about this topic, introduce this extremely complex abstract idea to them in a way that is very clear to them what you want to do. And so here are the 3 techniques again. This is obviously a summary of these techniques. Moving forward, when we are learning prompting, we should be spending most of our attention and time mastering these 3 high-yield techniques, and the remainder hundreds of techniques probably only represent small incremental improvements. I know I said I'd only give you 3 points, but I'm actually going to sneak in one last skill here. It's not a specific skill, but it's sort of a final check, and it's called meta prompting. Meta prompting is essentially taking your prompt, pasting your entire prompt into the GPT and asking it, how can I do better? In other words, it's asking the LLM to improve itself. You can actually use this technique for all 3 of these individual techniques that we talked about, right? You can ask the LLM to give you better few-shot examples, or you can have it generate 10 new few-shot examples for you. You can ask it how you did in terms of eliciting chain of thought and asking it to structure your prompt in a way so that chain of thought is better. And you can even use this technique to get you to give better instructions to the LLM, right? So what some people have done is they have actually asked the LLM to act as a UX designer and as an interviewer. And you ask the LLM, please interview me about my question. And then the LLM will actually ask you a series of questions. And in the process of answering these questions, you not only think about the problem in a step-by-step manner, you also are generating additional context for the LLM. In other words, this is a way you can use the LLM to actually externalize the information in your brain. Okie dokie. So in conclusion, when it comes to prompting, you have this massive toolkit of hundreds of techniques that are available to you, but do you really need to know all of these techniques, right? When is the last time you used this tool or this weird thing or whatever the hell this is, right? But you know what everyone needs in their house is one of these guys, right? The $20 starter IKEA toolkit that everyone has since college. I still have mine. I've built half my furniture using it. And so even as we get more sophisticated with our prompting and using AI, you're going to find yourself reaching for these same 3 or 4 basic tools over and over and over again. And with a small set of tools, you're probably not going to build the Eiffel Tower, but you can probably accomplish 80 to 90% of your everyday household tasks around the house. And I kind of want you to think about these same fundamental principles the same way. I'm going to leave you with one final thought. So a few months ago, Boston Children's made a splash in the news by posting this job listing asking for a full-time prompt engineering job. As time has gone on and the months have gone on, it has actually become more and more clear to me that as people start using AI more, prompt engineering and prompting isn't really a job, but it's a skill. And it's a skill that we all need to learn, right? Just like knowing how to Google, knowing how to navigate the internet, as time goes on, it's going to become harder and harder for you to keep up with society if you are not practicing this yourself. Um, in other words, right, you really need to learn how to prompt efficiently in order to get the most out of generative AI. Okay, that's all I have. Thanks for staying with me. If you found this helpful or interesting, this is actually a small excerpt from my 2-hour workshop that my co-fellow and I teach on prompt engineering for healthcare. Please feel free to reach out to us, shoot me an email. This is my LinkedIn if you want us to come and talk at your institution. But for now, I'm going to hand it over to Carl, who's going to be leading us through a live demo of how to use ChatGPT.
Awesome. Thanks, Dong. That was great. I particularly like the Gen Z discharge instructions. I think I think I'm going to start implementing that. Yeah, it was I was laughing incredibly. Okay, so I'm going to my name's Carl Preiksaitis. I'm physician here at Stanford. I primarily work in medical education, and I thought I would just go through some examples of how you can potentially be using some of these large language models in EM and EM related fields. I'm going to do a number of education examples because that's what I'm most familiar with, but I think some of the concepts sort of relate to other areas that you might apply some of these models and techniques. And a lot of the work that I'm doing and showing is rooted in some of the prompt engineering techniques that Dong talked about as well. They're just sort of built into the back end. So the first thing that I want folks to think about while I'm talking here is I want you to think when you're going to use AI, and if you're going to be somebody who's developing an AI use case or application, think about what you could potentially do now, either as a physician or whatever your particular field is. Like, what can you do now with AI that you couldn't do before? And those are really the human augmentation applications that I think are really exciting and unique. There's certainly a lot of room for automation, but I think if we can get towards augmentation, that's really going to be where we see a lot of the benefit. So along those lines, one of the first examples I have is, in medicine we do these things called journal clubs where we will start talking about an article. And we recently had a journal club not that long ago where we talked about this article, which is using using ketamine versus etomidate as an induction agent for critically ill patients. And if I'm just going to share a couple of different screens here. I'll share my second monitor so we can do this. So if we actually put this into ChatGPT and ask about the article, it's going to read the document and talk about this and go through giving us a little bit of a summary. But the way I talk about augmentation is, I really would like to know this paper uses Bayesian meta-analysis. And, if you're a medical student or a resident, you might not be familiar with all of the techniques. And you could ask the model, I'm not too familiar with Bayesian, can you give me an overview? And for things like mathematics and statistical methodology, I've found there's very little hallucination that occurs, and it tends to do a really good job giving basic explanations. So you could imagine if you were reading this paper and were confused about a technique that they used or had questions about the specific methodology, you could start asking questions and use ChatGPT to sort of clarify some of your things you weren't too sure about. And where I think this is an advantage in terms of education is it will allow people to do a lot more prep work offline, things that we as educators or faculty would often get asked about methodology and spend a long time explaining what Bayesian meta-analysis is and this terminology. We could ask people to use AI before they come to our discussion session and come in with just a much richer base understanding so that when we do get into discussions about the actual topics at hand, we can go into some of the details. And you could imagine even discussing like some of the accuracies for these models, whether there are any issues that people encountered prompting the models, and really incorporate AI into the workflow that you're doing from an educational perspective. So that's just one example. And another example that I have is communication practice. So one of the things that that physicians need to be trained in is how to communicate effectively with patients. And there are a number of scenarios where you can imagine that communication and having a good bedside manner is very important to effectively care for patients, but it's a hard thing to train. We do a lot of role playing and scenarios, and practicing that takes a lot of resources. It takes dedicated time to run a simulation or to have somebody do one-on-one practice for communication. And AI is actually really good at simulating communication. So another example that I have, and I'll run it off my phone here, is doing a communication simulation with ChatGPT. So I'm gonna log into uh, the phone app and just start a new conversation here. And I'm going to use the audio input, and hopefully you guys will be able to hear this. But hey, I'm doing a communication simulation practice. I'm an emergency physician, and I want you to simulate the role of a patient and help me practice breaking bad news to the patient. After we're done here, I just want you to jump right into the role of the patient.
Got it, Carl. I'm ready whenever you are. Let's start the simulation.
Hey, Mr. Johnson, my name's Dr. Preiksaitis. I'm coming back. I wanted to update you on some of the test results we got.
Hi, Dr. Preiksaitis. Thanks for coming back. I'm a bit anxious. What did the tests show?
Yeah, unfortunately, the news was not what we were hoping for. We got the results of your CT scan, and unfortunately, it shows your cancer has progressed.
I see. That's really hard to hear. What does this mean for my treatment options now?
Yeah, I'd love to get into your treatment options a bit more with you, but I wanted to just check in and see how you're dealing with that news. I know it's hard to hear.
It's a lot to process. I'm feeling overwhelmed, but I appreciate you being straightforward with me. What are the next?
Okay, so that was a serious scenario, but you get the idea, and you could do similar implementations just based on the prompting that you give for communicating with consultants, talking to people on the phone. And there's a lot of ways to build in some of that prompt language in the back end so that you could build an application where learners or other people could just practice their communication skills and actually get feedback on how they're communicating with patients. The next example I'm going to share here is an individualized learning example. So, you know, we do a lot of teaching and teaching people while we're seeing patients in the department. We have medical students and have residents, and a lot of times there's a need to give sort of a little bit of additional information about a case that they've seen, or you want to share information about a topic. And sometimes it's hard to figure out exactly what you're going to talk about. So this is a prompt that I engineered for coming up with teaching suggestions. So it'll ask you what level of learner you're teaching, and you can say, I'm working with third year medical student. And it asks if there's any typical areas that they've been struggling with. And you can say acute asthma exacerbation. Great. Yes, that works. And what it will do is give you basically a 5-minute summary on key talking points related to asthma exacerbation management. And you as the expert, if you're the physician working with this, you'd have to check to make sure everything agrees with what you would put up there. But it's a good way to probe your memory and to give you sort of a framework. It'll also give you an idea of what you could potentially write up on a whiteboard while you're giving the talk. And, a lot of times there's writing block that occurs for teaching where you're just looking for a topic, you want to teach something, and you're not exactly sure how to come up with something on the fly, or you have things that you do all the time and you're looking for something new. So this, doing a prompt like this is a great opportunity to come up with some other teaching ideas and to really individualize an educational experience to the person that you're working with on that day, rather than falling back on something generic. The next example I was going to give is this is moving a little bit more away from augmentation and more to some automation things. So something that I've done some research in and have done some work with is using generative AI for letters of recommendation. And there's a whole discussion we could have about the pros and cons of doing that. If you're interested in reading some research on the area, you can review this paper that I did a little while ago. And what we did in this paper is we actually created letters of recommendation for promotion, and they were authored by humans as well as by artificial intelligence, and then had expert reviewers review the letters and see if they could determine which ones were authored by AI and which weren't, and which ones they viewed as more supportive of promotion and less supportive. And people couldn't really tell the difference and viewed the letters. There wasn't really a difference in terms of how favorably they viewed the letters between AI and human authorship. Although when people believed that the letter was authored by AI, they were somewhat biased against it, which, there's a big discussion to have about disclosure of AI use and letter authorship and some of those other considerations. But it is a great way to get you started if you have to write a letter of recommendation. So let's go in and give an example of how to do that. So just do a new chat here. And then I have this short prompt that I wrote where you're acting like an expert in writing letters of recommendation. And then we just find some of the documents that I have. So I have an example of my CV, as well as some guidelines for promotion that we created.
Carl, just so you know, we can't see what you're doing.
Yeah.
There you go. Thank you.
And then I'm just going to put it in. And this is a PDF and a document, and it will draft a letter that's based on some of the guidelines. It fills in some of the details based on the CV and looks for things in the CV that would align with the guidelines for promotion. And of course, this would need to be, reviewed and adjusted. But a lot of the things that go into letters of recommendation tend to be fairly boilerplate items. Reviewing the CV, entering pertinent details, academic publications, scholarly work. A lot of those things could be automatically put in by AI. And then the stuff that I think is really meaningful in a letter, like how you know the candidate personally, what your experiences with them have been, those things you can spend a little bit more time working on and adding those elements to the letter rather than going through and summarizing elements of the CV. And you could pick any number of use case where you need to draft an email or draft writing. There's lots of examples of those items available on the web. Okay. Let me go to the next thing I wanted to show for you guys is an AI application. And there's a number of different AI applications. This is one that I just think is particularly cool and exciting. This is called Notebook LM. It was developed by Google, and it's still sort of an experiment right now from one of their labs. But I think it has some pretty cool use cases and applications. So let me just get this pulled up. Zoom. Okay, so the way it works is you create a notebook, which is essentially it's essentially a database of files that you're going to draw off of and can ask questions about. So one of the things I did, last year's STEMI X conference, all the YouTube videos are available online, and you can add sources. You can add things from your Google Drive, Docs, slides. You can link to websites. You can add direct text or YouTube videos. So I just went in here and linked all the STEMI X presentations from last year, and you can ask questions. You can also see sort of a summary. So it'll give you a summary of the transcripts, and then you can ask their suggested questions, or you can ask questions based on the content that's in there. So, one of the suggested questions was, what are the biggest challenges to implementing precision emergency medicine? And that was a big feature of STEMI X last year. And it will take a little bit of time here, but then come up with examples from the videos, along with references that you can go to. It bases it on the transcripts from the videos. And you can get some really nice summaries. You can imagine this if you're a student. You could upload a lot of course materials, transcripts from lectures, and you could use it to generate study guides. They even have a preset here where you can generate a study guide. You can ask particular questions like who won the pitch competition last year, or at so here's a study guide that it made, and you can ask specific questions. Right, so Rocket Doctor won last year, and you can go in and verify those things. And one thing that I think is really cool, let me ensure my sound's added, is you can actually, based on the contents in here, you can create a podcast. So let's listen to what that sounds like.
Get ready to have your minds blown, because today We're diving headfirst into the future of emergency medicine.
We're talking about a future where tech and patient needs, they kind of collide, and it's happening right now. This isn't some sci-fi movie.
We're talking AI, virtual care, even hospitals at home becoming like as normal as a trip to the doctor.
And to get you right into the thick of it, we're going behind the scenes at Stanford Medicine's STEMIX 2023 conference. They've got doctors, entrepreneurs, even a pitch competition all buzzing about where EM goes next.
And let me tell you, this isn't just some pie-in-the-sky dreaming. These are real-world solutions, right? These are doctors who've been on the front
So
lines,
you
seeing
can
the
see,
problems firsthand.
And they're not afraid to take
basically will
risks.
choose what it wants to do a conversation about. It develops like audio, AI generated audio of two hosts, creates dialogue. And, if you're studying or you want a review of a topic, it's, I love podcasts, but there's not always a podcast for what I want to find information on. And you can experiment with all sorts of weird things. I took the policy from my daycare for my kid and made a podcast about it, and just to see what it would sound like. And it talked all about like their illness policies and debated about it. So there's a lot of cool use cases that you could try experimenting with this. Okay, let's go on. Okay, just a couple more examples that I want to share with you guys. So doing some degree of automated review. Dong mentioned a paper where they used GPT to review some of the articles for inclusion or exclusion. And there's a good body of literature that now supports that practice. And you can do similar things with medical notes or transcripts. And if you have programmatic access to some of the EHR data, you can, if you have a safe way of doing it, if the data is de-identified, which we have a repository of de-identified patient data here, you can do a number of different things. This was a study that was done recently by some folks here at Stanford that looked at clinical actionability of emergency department imaging reports, and GPT-4 was able to correctly identify a number of those. I did something recently. We were doing some work on STEMI cases and created some code to read through discharge summaries from patients and try to determine whether they should be included in our study cohort or not. And it came up with, I asked the model to review the discharge summary and see if this patient had a STEMI, if they went to the cath lab from the ED, and to try to infer that. And it did an excellent job. We validated this against human reviewers, and it was completely accurate from our data set, and gave some justification for each one. This is one that was presented in, and it was able to actually tell the occlusion of what branch was stented. Here's another one that was out of the data set that went to the cath lab or actually had a STEMI, but ended up having 3-vessel coronary disease, so needed a cabbage. So somebody that sort of through our filtering entered into our data set, but then using an LLM, we were able to validate that they actually shouldn't have been included because they didn't go to the cath lab, they had a cabbage. So lots of possibilities for automating data analysis, and working more efficiently with data. The last example that I want to show is going to be data analysis, and you can do this with sort of any sort of data that you're working with. I have an example here with some de-identified EHR data. And I think one of the unique things ChatGPT is good at doing is it has this code interpreter functionality. So it's able to take the LLM and write code, Python code usually, in a sandboxed environment, and execute analyses on it. So this is a CSV data set of a number of presentations. And you can see when it says analyzing, it's actually writing writing Python code, it'll start to look at what the categories are here in the data set. And it'll give us an interpretation. It's not moving too, oh, great. Okay. So it's got 47 columns. It's got some information about length of stay, disposition, admitted services. Could you tell me what the top 10 chief complaints are? And you can see it'll write some code to take a look at this and analyze it. These are actually, yeah, so these are specific, not free text chief complaints, but these are classifications we did on this data. And you could ask for graphical representations. So show me a chart of ESI scores. And you can do graphical representations, anything you can do with Python, you can basically run in here. You can do statistical analyses, you can do correlations, generate figures, and the amount of data that you can upload is up to 512 megabytes, which is a very large CSV file. So you could do file analysis on thousands and thousands of columns of data. So really powerful, a lot of different applications. I probably wouldn't use this for, for the final arbiter of any statistical work that I'm doing, but it's a great way to do some exploratory analyses. I think I'll end it there because we're almost out of time, and then see if there are any questions I can answer.
I see that Andrew O has had his hand up for a while. Andrew, do you still have a question?
If you do, please put it in the chat. Maybe I'll ask one of the questions there about getting personal feedback. How have you learned that the LLM learns about you in your use of it?
There's like an internet meme going around right now where you can people say, ask ChatGPT what's something that you know about that it knows about you that you wouldn't know about yourself. And the historically you had to put all of your context into who you were and what questions you were asking into your prompts. Now there's this memory feature in ChatGPT that will store some information based on your last queries. I found it to be sort of variable. It tends to just remember what the last couple of conversations were about. So I think if you want feedback on something you're working on, you would probably it's probably more reliable to provide context about who you are and what sort of feedback you're looking for than to rely on what the model knows about you. And you can turn off that feature too. And while I was demoing it, we were doing it in sort of a private version that won't store any information.
Yeah, it is interesting. There is this place you can go to on the GPT app that'll list what it knows about you. And it's always an interesting exercise to go ask ChatGPT in a new chat window, like, hey, like tell me about me, right? And it'll list out a bunch of things that are actually mostly pretty accurate, but it gets things wrong. Like, for example, I did asked a bunch of cardiology questions, and it like hallucinated that I was a cardiologist. So your mileage may vary.
There you go. Well, we're going to move on to the next session. I can't thank you guys enough. That was amazing. I would double click on the first chat there where I think these presentations were amazing. I learned a ton as well, and I'm going to continue to use a lot of these techniques moving forward. Just a quick pitch for our next pitch. So the next session will be our pitch competition. There are going to be some amazing companies in there, and I'm really excited about the feedback they're going to get. So please move on to our next session. Dong, Carl, thank you so much. Really appreciate it.
Thanks everyone for tuning in.
Feel free to reach out to us if you have any questions. We're happy to answer.